This is Mr. Rahul Hunkalas, Assistant Professor and Workshop Superintendent from NB Navle Sinhagad College of Engineering, Kegaon, Solapur. I am having more than 12 years of teaching experience and my specialization in mechanical design engineering. Now today we are going to discuss about the very important point in IC engine, that is engine emission and its control. We know by burning of air fuel mixture in SI engine or in CI engine, it produces exhaust gases. Once the exhaust gases will come out from the engine itself, it contains the different types of pollutants, and these pollutants are very much hazardous to the human as well as to the nature. There are the different effects of these particular pollutants like global warming, acid rain, smoke, odor, and there are some respiratory and health hazardous problem. So it is very important to study the different types of pollutants and how one can control these different types of pollutants. Now we have to understand one by one the different pollutants for SI and CI engine emission. As the exhaust gases will come out by burning inside the engine cylinder, it contains the different types of pollutants, or we can say the different types of emissions. Engine emissions can be classified into two categories. One is a exhaust emission and another one that is a non-exhaust emission. First of all, we'll understand the different types of exhaust emission in the both SI and CI engines. As the different types of exhaust emissions are: the first one, unburnt hydrocarbons, that is also called as a HSC, oxides of carbon, that is nothing but CO and CO2, that is carbon dioxide and the carbon monoxide, oxides of nitrogen, that is NO or NO2, oxides of sulfur, that is SO2, SO3, and the last one, particulate matter, that is PM, soot, smoke. These are the different types of exhaust emission through SI and CI engines. With the help of this diagram, we can understand how the different emissions will happen as per the different air fuel ratio. On the x axis we have the air fuel ratio equivalence in terms of phi, and on the y axis we have the amount of emissions in exhaust flow. Now we have the different curves here. We can see the first curve, that is the curve of NOx, the second curve, this is the curve of hydrocarbons, the third curve, this curve is nothing but the curve of carbon monoxide, that is CO. The left portion is for lean mixture, the right portion is for the rich mixture. Now what we can understand with the help of this graph, as we can see with the help of this diagram, as air fuel ratio is going to increases, if you see in the NOx graph, we can see as the air fuel ratio is increases, the NOx value, that is nitrogen dioxide value in the pollutants, is going to increases. Similarly, as air fuel ratio increases, if the mixture become too rich, the hydrocarbon value is going to increases, and similarly as air fuel ratio is going to increases, the mixture is too rich, the CO value is again going to increases. But the value of NOx, we can see after one limit the value of NOx is going to down even the mixture is too rich. This is the meaning of this particular graph itself. Now similarly we have the another graph, again the different pollutants like NOx, like hydrocarbons, like CO. We can see with the help of this graph, y axis indicates NO, CO and hydrocarbon concentration. Again on the x axis we have the air fuel ratio and its equivalence. As the air fuel ratio increases, as carbon monoxide will going to increases, then how there will be changes in the hydrocarbons and how there will be changes in the carbon monoxide, nitrogen dioxide, we can understand with the help of this second graph. Similarly, when we are going to talk about the next varieties of emission, that is nothing but hydrocarbon emissions. Again, these hydrocarbon emissions are present in both SI engines and in CI engines. Now the causes for hydrocarbon emissions from SI engines are, the different causes are there. The first cause of the hydrocarbon emissions through the SI engine, that is incomplete combustion. Because of incomplete combustion, many of times hydrocarbons may come out from the exhaust gases, then crevice volumes and flow in crevices, leakage past the exhaust wall, wall overlapping, deposits on wall, that is carbon deposits on wall, then oil on combustion chamber walls, etc., etc. These are the few causes for generation of hydrocarbons. Also, when CI engines operates with overall lean mixture, it has only 1/5 of hydrocarbon emissions of an SI engines. In general, CI engine has 98% of combustion efficiency. It means only 2% of hydrocarbon efficiency. Where all CI engines also have an hydrocarbon emissions for some of the same reason as we have just discussed above over here, and that is like wall deposit, that is a carbon deposit, absorption, oil film absorption, crevice, etc., etc. Now we are going to talk about the next type of emission, that is a carbon monoxide or CO emission. Now here we can understand the reactions of this particular carbon plus oxygen, then it becomes the carbon monoxide. Here we can see then the CO is one kind of a colorless and odorless emittents which come out from the exhaust gases. This is one kind of a poisonous gas. The things are present over here, you can read it. Again the next one, that is oxides of nitrogen, that is NOx. The different reactions are present over here, you can read it. Again this is one kind of emittents which can produce from the exhaust gases. It is generally present in the CI engines more, which is as compared to high SI engines. Similarly, the next one, that is a photochemical smog. This is also one kind of emittents which will produce by burning of air fuel mixture inside the engine cylinder. The reactions are present over here. All the reactions is present over here, and this is very hazardous and this is very harmful to the ozone layer. The next one, that is about the particulates is also one kind of emittents. The exhaust of CI engines contains carbon soot particulate that are generally rich fuel zone within the cylinder during combustion. So these are the different pollutants which may come out by burning of air fuel mixture in the engine cylinder itself. Thank you for watching the videos.